From question 9, there's the 3 ones there. I just thought we'd choose one to go through. The question says find the foot of the normal. So effectively what we're talking about is if we've got a plane, I'll just draw a sort of plane there, then the foot of the normal would be a point that's on the plane, okay, and then we'd have a normal coming out. It says from point A, which is somewhere in space. So point A for question A is 1, 0, 2. So I'm going to label that over here, 1, 0, 2. So the foot of the normal would be if I went straight down, in this diagram straight down, from A to the plane and hit that 90 degrees so that it was normal. It wants to find where the foot of the normal is. So what's the coordinates of this point here? We'll call this point N. And then, so what's the shortest distance from A to N? It's got to be the normal. Okay, so just going through an example, it's the sort of thing you might come across. So we know the point A. We know that the plane has an equation which is 2x plus y take 2z, and we'll write it in the normal form, which is to put the constant on the other side of the equal sign. So from that, one thing we know is that the normal vector, okay, that comes from the plane, we can get directly from this formula here. Okay, we can get that and just say that the normal is going to be equal to those coefficients. So it's 2, 1, negative. What's doing that? Negative 2. Okay, so that's read off there. That's something that you'll probably have to do regularly, is to know that's the normal. Okay, so we want to find the coordinates of n. What we can do is we can write for the line A to n, okay, we can write the parametric equations for it because we know a point. The point is the point at point A, which is 1, 0, 2, and we know the direction vector is 2, 1, minus 2. Okay, so we've got a direction and a point, which means we can write the parametric equations for the line. So x equals 1 plus 2 is t as the parameter. Y is equal to 0 plus 1t, so just t. Z equals 2 take 2t. So that's the parametric equation for the line A to N. Okay, but we also know that that line, the line A to N, meets the plane I'm not going to rewrite the equation, but it meets that plane where, so if I use the plane and I substitute in the x, y, z coordinates, so 2 from the plane, lots of x, which is 1 plus 2t, plus y, lots of, I'll just plus y is equal to t, so t, plus, in fact it's take, isn't it, so take 2 lots of z, and z is 2 take 2t, and that must equal negative 11. Okay, so we're just substituting the points from those parametric equations from the line, putting it into the plane, so that we're saying, right, for this to be true, we should now be able to simplify that for t. So we're going to get 2 plus 4t plus t take 4 plus 4t equals negative 11. And that comes out to being 9t equals negative 9t equals negative 1. So that tells us that the parameter t for that line where it hits the plane, okay, that must be -1, which means we can work out that n coordinates, the coordinates of n, which is what is when t equals -1. So we substitute that back in to our original parametric equations there. Okay, so when, scroll that up a little bit, no I can't, when t equals -1, the coordinates are going to be 1 plus 2 lots of -1, so -1, and then -1 substituting in, and then 2 take 2 lots of -1, which is 4. So therefore n coordinates are -1, -1, 4. Okay, so that's the first part. That just finds the foot of the normal. Okay, that finds the coordinates for it. And the second part says, what's the shortest distance? Well, we've now got the coordinates for a and n. We just need to know the distance of that vector. So part B, all we're going to do is say for the vector an, what's its absolute length? All right, so it becomes square root, and it's going to be, I'm simplifying here, you can work through it, plus 1 squared plus 2 squared, which is the square root of 9, so it equals 3 units in length. Okay, so that's just an example from that. Remember, I can't remember whether it's about question 16 or 17 from textbook. Don't worry about doing. It's beyond what we need to worry about. We're only really working in Cartesian form for the planes.